Hello. Today we are going to continue our lecture with chapter 3 because during the face-to-face lecture in the class we finished chapter 1 and 2. So we continue with chapter 3, which is torsion, and these are the content for this chapter. So we have a little bit of introduction and then definition of torsion, deformation in a circular shaft, stresses within elastic range, angle of twist within elastic range, statically indeterminate shaft, design of transmission of shaft, and stress concentration in circular shaft. The learning objectives for this chapter: at the end of this chapter, student should understand the concept of deformation due to torsional load in a circular shaft. And also, students should be able to calculate stresses and angle of twist of a shaft within elastic range of torsional load. You should know what is the meaning of elastic range. In addition, you should also know to do the calculation in statically indeterminate torsional load. Also, you should understand the concept of design and calculate the power transmission of a shaft. And finally, you should be able to calculate the stresses, power and torque for shaft which has a different diameter of cross section that create stress concentration area. The definition of torsion. Torsion is an action of twisting an object. For example, this rod, we twist at one end clockwise and at another end at anti-clockwise. So that means we are twisting this solid. So when we are twisting the solid, we are expecting that this object will break and create a plane like this. Okay, so the twist to an object will create torque. So you apply force to twist, and this force will create torque, and this torque will produce shearing stress. Shearing stress is written as tau. Previously, I told you in the class that stress can be divided into two. One is normal stress, which is written with the symbol sigma is equal to F over A or equal to P over A. And the second one is shear stress, in which typically it is written using the symbol tau is equal to F over A. So normal stress is the condition in which that, for example, you have a solid cylinder or solid shaft like this, and then you pull this shaft at both ends with loads. This load is known as axial load because it is perpendicular to to the cross section area. So this is 90 degree. So this is axial load. So this axial load will produce normal stress, in which it can be calculated using this equation. On the other hand, the shear stress, let's say you have the similar cylinder, but you give force at one end from here and at another end here. So you are expecting that this cylinder will break somewhere. It's as if that you are cutting to a plane here. So this is the area. So similarly, this also will fail somewhere in the road, but perhaps it will fail here. So this is the cross section, and this is the cross section for this cylinder. So these types of force, in terms of the directions of these forces, is known as transverse load. So this transverse load will cause a shear stress, in which it can be calculated using the same equation. So this is the area for this, and also the same. This one is the area.